Welcome to episode 5 of our PMI-ACP certification study series. In this episode, we'll cover adaptive planning, which falls under domain fee of the exam content outline. Question 39. What is rolling wave planning and why does Agile approach planning this way? Take a moment to think about your answer before we continue. Domain 5 covers adaptive planning weighted at 12% on the exam. This domain addresses how Agile teams plan work while remaining responsive to change. Rolling wave planning is the core concept. It means we plan in waves, detailed for the near term, high level for the long term. As time passes and we learn more, we add detail to upcoming work while keeping distant work at a high level. Why this approach? Because planning accuracy degrades with time. This phenomenon is called the cone of uncertainty. At the beginning of a project, our understanding is limited. Estimates might be off by a factor of 4 or more. As we progress and learn, uncertainty narrows. By the time we're executing work, our estimates are much more reliable. Given this reality, investing heavily in detailed long-term plans is wasteful. Those details will change as understanding grows. The effort spent creating them is lost when they're revised. Worse, detailed plans create an illusion of certainty that can prevent appropriate adaptation. The planning onion visualizes this concept. At the center is today's work, known in great detail. Moving outward, we have iteration planning covering the next 2 to 4 weeks, release planning covering 3 to 6 months, product planning covering months to years, and portfolio or strategic planning covering years. Each layer has less detail than the one inside it. For exam scenarios, this means questions about long-term planning should be answered with high-level approaches. If a question asks how to plan work 18 months from now, the answer involves themes or epics, not detailed user stories. If a question asks how to plan next week's work, detailed tasks are appropriate. The iteration, typically a sprint, is the fundamental planning horizon. Within a sprint, the team has a detailed plan. They know which backlog items they're completing and how they'll approach the work. This plan provides the stability needed for focused execution. Between iterations, the plan adapts. Based on what was learned in the last sprint, priorities might shift. New stories might be added, scope might be reduced. This adaptation is not failure, it's the process working correctly. For the exam, answers that suggest detailed upfront planning for an entire project are usually wrong. Answers that suggest just enough planning with detail appropriate to the time horizon are usually correct. The planning never stops. It's continuous, just in time, and progressive. One more concept. Planning in Agile is a verb, not a noun. Traditional project management produces a plan, a document that guides the work. Agile teams engage in planning, an ongoing activity of understanding work and adapting approach. The artifact matters less than the activity. Question 40. How do story points and planning poker support Agile estimation? Take a moment to think about your answer before we continue. Agile estimation separates two things that traditional estimation combines: size and duration. We estimate how big something is, then derive how long it will take based on the team's historical velocity. Story points are the most common unit for sizing. A story point is a relative unit combining complexity, effort, and risk. Relative is the key word. We don't define what one story point means in absolute terms. Instead, we compare items to each other. If story A is about twice as complex as story B, and story B is 2 points, then story A is roughly 4 points. Why use relative sizing instead of hours? Several reasons. First, humans are better at relative comparison than absolute estimation. We can easily say that this item is bigger than that one. Saying exactly how many hours is much harder. Second, relative estimates are more stable. If the team composition changes or tools improve, our estimates become invalid. Point estimates remain valid because they're relative to other work. Third, points separate estimation from commitment. Saying, this is a 5-point story doesn't mean this will take 5 days. It means this is roughly the same size as other 5-point stories we've done. Planning poker is a consensus-based technique for story point estimation using Fibonacci numbers, 1, 2, 3, 5, 8, 13, 20, and so on. Why Fibonacci? Because the gaps grow as numbers get larger, reflecting increasing uncertainty. The difference between a 2 and a 3 is meaningful. The difference between a 20 and a 21 is noise. The process works as follows. The product owner reads a user story and answers clarifying questions. Team members discuss what's involved without stating estimates yet. Then each team member privately selects a card representing their estimate. Cards are revealed simultaneously. The simultaneous reveal is crucial. It prevents anchoring, where the first number spoken influences everyone else. If a senior developer says 5 before others have thought it through, less experienced members often defer rather than disagree. Private selection followed by simultaneous reveal surfaces genuine differences. When estimates differ significantly, the highest and lowest estimators explain their reasoning. Often, the low estimator is missing something the high estimator saw, or vice versa. The discussion that follows is actually more valuable than the number itself. Through dialogue, the team builds shared understanding of the work. After discussion, the team estimates again. Usually consensus emerges. If not, additional discussion occurs. The process continues until the team aligns. For exam scenarios, planning poker is appropriate when estimating backlog items, particularly during sprint planning or backlog refinement. It works best for moderate-sized backlogs. For very large backlogs, faster techniques like affinity estimation or t-shirt sizing are more efficient. Affinity estimation is used when you have many items to estimate quickly. Items are written on cards or sticky notes. The team silently sorts them into columns representing size categories, like small, medium, large, and extra large. It's fast because there's no discussion of individual items, just comparative placement. T-shirt sizing uses extra small, small, medium, large, and extra large as size categories. It's particularly useful early in planning when requirements are vague. It conveys relative size without false precision. For the exam, understand when each technique is appropriate. Planning poker for detailed estimation of modest backlogs, affinity estimation for rapid sizing of large backlogs, t-shirt sizing for early stage roadmap planning. Question 41. What is velocity and how should it be used? Take a moment to think about your answer before we continue. Velocity is the number of story points completed by a team in an iteration. It's a historical measure of capacity, not a target to be achieved. Calculating velocity is simple. Sum the points of all stories completed, meaning they meet the definition of done, in the sprint. If a story isn't done, its points don't count, even if it's 90% complete. This maintains integrity. Partial credit creates false signals. Velocity is used for forecasting. If the team averages 20 points per sprint and the remaining backlog contains 100 points, we can estimate 5 sprints remaining. This is not a precise prediction, but a reasonable forecast based on historical data. For exam scenarios, a critical rule is that velocity is unique to a team. Never compare Team A's velocity to Team B's velocity. If Team A completes 20 points per sprint and Team B completes 40, this does not mean Team B is twice as productive. Team B might estimate more generously, including less complexity per point. Velocity is calibrated to the team that generated it. Management sometimes wants to increase velocity as a performance goal. This is counterproductive. If velocity becomes a target, teams will inflate estimates to hit the number. A story that was 5 points becomes 8. Velocity goes up, but actual output doesn't change. The metric becomes meaningless. The appropriate use of velocity is planning and forecasting, not performance evaluation. How much can we reasonably commit to this sprint based on what we've historically completed? When might we finish this release based on remaining work and past throughput? Burn down charts visualize progress within a sprint or release. The vertical axis shows remaining work. The horizontal axis shows time. Ideally, the line trends down towards 0. If the line is flat or rising, the team is behind, or scope is increasing. Burn-up charts offer a complementary view. One line shows work completed, trending upward. Another line shows total scope. The gap between them is remaining work. Burn-up charts are better for detecting scope creep. When the total scope line jumps up, it's immediately visible. For exam scenarios, understand what these charts reveal and when to use each. Burn down for tracking progress toward a fixed scope. Burn up for tracking progress when scope might change. Question 42. How should teams handle estimation uncertainty, and what are spikes? Take a moment to think about your answer before we continue. Sometimes teams face work they cannot estimate because they don't understand it well enough. Perhaps it involves unfamiliar technology. Perhaps requirements are unclear. Perhaps integration with an unknown system is required. Forcing an estimate in these situations produces a guess, not an informed projection. Agile addresses this through spikes. A spike is a time-boxed investigation whose output is knowledge rather than working software. The team might spend 2 days exploring an AP1, prototyping an approach, or researching options. At the end, they know enough to estimate the actual work accurately. Spikes have several important characteristics. They are time-boxed. You don't spike until you feel ready. You spike for a fixed period and then assess what you've learned. This prevents research from expanding indefinitely. The output is knowledge, not deliverables. A spike might produce a prototype, but the prototype isn't the goal. Understanding is the goal. The prototype might be thrown away once the learning is captured. Spikes enable estimation. After completing a spike, the team can estimate the actual implementation story with confidence. The unknown has become known. For exam scenarios, spikes are appropriate when teams cannot estimate work because of technical uncertainty. If a scenario describes a team guessing at estimates for unfamiliar technology, a spike is the recommended response. Complete the spike first, then estimate accurately. Another aspect of estimation uncertainty is the wideband Delphi technique, an expert-based estimation approach. A panel of experts provides estimates independently. Results are shared anonymously. Outliers explain their reasoning. Experts revise estimates. This iterates until consensus emerges. Planning poker is actually a variation of wideband Delphi applied to agile contexts. The principles are the same: independent estimation to avoid anchoring, discussion of differences, and iteration toward consensus. For the exam, remember that estimation is not commitment. Estimates are forecasts based on current understanding. They will be wrong. The question is how wrong and what we do about it. Agile's approach is to estimate frequently in small batches with short feedback loops. When estimates are off, we learn quickly and adapt. Question 43. How should a team respond when their velocity suddenly drops? Take a moment to think about your answer before we continue. This scenario tests understanding of velocity as a diagnostic tool rather than a performance target. Scenario: a team's velocity has been stable at 20, 22, and 21 story points for 3 sprints. In the 4th sprint, velocity drops to 12. Management is concerned. What should happen? First, understand what's happening. A significant velocity drop signals that something changed. It's information, not necessarily a problem. The correct response is investigation and adaptation, not pressure to recover. Wrong responses include demanding the team work harder or longer. If the velocity drop is caused by external factors like sick team members, additional work won't help and will create resentment. If it's caused by hidden complexity, overtime leads to burnout without addressing the root cause. Another wrong response is adjusting estimates to restore the appearance of normal velocity. This gaming of metrics destroys the team's ability to plan accurately. The correct response involves the retrospective. This is precisely the forum for inspecting what happened and adapting. Possible causes of velocity drops include technical debt coming due. Perhaps the team has been cutting corners, and now those shortcuts are causing problems. Code that should take hours takes days because of accumulated poor quality. External interruptions. Perhaps team members were pulled into meetings, support issues, or other work that isn't reflected in story points. Hidden complexity. Perhaps the stories in this sprint were more difficult than estimated. Maybe they encountered unexpected challenges, team changes, Perhaps someone was sick, on vacation, or reassigned. Velocity naturally decreases with reduced capacity. Personal issues. Perhaps team members are dealing with challenges outside work that affect their focus. The investigation should be curious, not accusatory. The goal is understanding, not blame. Once the cause is identified, the team can decide whether action is needed. If the cause is temporary, like illness, no systemic change is required. Next sprint will likely recover. If the cause is systemic, like technical debt, the team might dedicate capacity to paying it down. They might allocate 20% of each sprint to refactoring and quality improvement. If the cause is external, like interruptions, the Scrum Master might need to address organizational issues, shielding the team more effectively. For the exam, the key insight is that velocity fluctuations are normal and informative. They trigger inspection and adaptation, not panic or punishment. Teams that are pressured about velocity learn to game the metric rather than genuinely improve. Question 44. What should happen when management asks for detailed long-term estimates? Take a moment to think about your answer before we continue. This scenario tests understanding of rolling wave planning and appropriate estimation precision. Scenario: management asks the team to provide hour-level estimates for all features planned for the next 12 months. They want a detailed project plan with specific dates. How should the team respond? First, understand management's underlying need. They probably want predictability. They need to make budget decisions, coordinate with other initiatives, and set stakeholder expectations. These are legitimate needs that deserve respect, even if the requested approach is problematic. Now understand why hour-level estimates for 12 months out is problematic. The cone of uncertainty means that estimates this far out are inherently unreliable. Requirements will change, technologies will evolve, team composition might shift. An estimate that seems precise, like feature X will take 40 hours and be completed on March 15th, creates false confidence. When reality diverges, as it inevitably will, trust erodes. The Agile response involves several elements. First, educate management about estimation realities. Explain the cone of uncertainty. Show historical examples of how early estimates compared to actual outcomes. This isn't about refusing their request. It's about helping them make better decisions. Second, offer appropriate alternatives. For the 12-month horizon, provide high-level estimates in story points or t-shirt sizes, grouped into themes or epics. This gives directional guidance without false precision. Provide a roadmap showing likely sequence and rough timing with explicit acknowledgement of uncertainty. For the nearer term, perhaps the next quarter, provide more detail. Features can be estimated more specifically. Rough dates can be projected based on velocity. For the immediate sprint, provide full detail. The team knows exactly what they're working on and can commit to specific deliverables. Third, propose a progressive planning approach. Rather than trying to plan everything up front, schedule regular planning checkpoints. Each quarter, refine the next quarter's plan in detail while updating the longer-term roadmap. This provides the visibility management needs while respecting the reality of uncertainty. For the exam, this scenario tests whether you can balance organizational needs with Agile principles. The wrong answer is to simply comply with the request, producing detailed long-term estimates that will be wrong. Another wrong answer is to refuse outright, creating conflict without addressing legitimate needs. The correct answer involves collaboration, understanding the underlying need, educating about constraints, and proposing alternatives that serve everyone better than the original request. Question 45. How do burn-down charts and burn-up charts differ, and when is each appropriate? Take a moment to think about your answer before we continue. This question tests your understanding of common Agile tracking tools. A burn-down chart shows work remaining over time. The vertical axis represents remaining work, typically in story points or hours. The horizontal axis represents time. The line starts high and should trend towards zero by the sprint or release end. Burn-down charts answer the question, Are we on track to finish? If the line is trending towards 0 at the expected pace, the team is on track. If the line is flat or declining too slowly, they're behind. If the line is declining faster than expected, they might finish early or can pull in additional work. An ideal burn down shows a relatively steady decline. Real burn downs are rarely ideal. The line might plateau when the team encounters obstacles, then drop quickly when they're resolved. This variability is normal. A burn-up chart shows work completed over time, plus a line showing total scope. The completed work line starts at 0 and trends upward. The scope line might remain flat if scope is fixed or might change if scope changes. Burn-up charts answer additional questions. Not only are we on track, but also, is scope changing? When the scope line jumps up, everyone can see that more work has been added. When it jumps down, scope has been cut. This visibility makes burn-up charts superior for situations where scope might change. Traditional burn-down charts hide scope changes. If you add 10 points of work and complete 5 points of work, the burn-down line stays flat. It looks like zero progress. But really, you made progress while absorbing a scope increase. The burn-up chart makes both visible. For the exam, both charts are useful. Burn-down is simpler and widely used for sprint-level tracking where scope is typically fixed. Burn-up is more informative for release-level tracking where scope might evolve. Related to these is the cumulative flow diagram, or CFD. This chart shows how many items are in each workflow state over time. Bands represent states like to do, in progress, and done. The width of the in progress band indicates work in progress. The horizontal distance between entering and exiting a state indicates cycle time. CFDs are particularly useful for Kanban-style flow, where work isn't batched into sprints. They help identify bottlenecks. If the in-progress band widens, WIP is increasing. If the horizontal distance between bands grows, cycle time is increasing. Both are warning signs. For exam scenarios, know which chart to apply: sprint tracking, burn down; release tracking with possible scope changes, burn up; continuous flow analysis, CFD. That concludes episode 5. We covered 7 important concepts. Take time to review these questions and answers, and practice applying these concepts to scenario-based questions. In the next episode, we'll continue exploring the PMI-ACP exam domains.